Kirchhoff voltage law continuation. Question number 3. Find the current delivered by 12-volt battery. Find the current delivered by 12-volt battery. This is given as 3 ohms. This is given as 5 ohms. This is given as 2 ohms. Then this is 4 ohms. And this is 12 volts. This is 4 ohms. So first step is assume the direction of current. I1 is flowing. I1 flows I2. So this will be I1 minus I2. I2. This will be I3. This will be I3. I2 minus I3. Then this will be I1 minus I2 plus I2 minus I3. So I2 cancel. I1 minus I3. And then here it will be I1. Why will this be I1? Because it will be I1 minus I3 plus I3. So I3 cancel. Therefore I1 will remain. Now, so let's apply the KVL. So assuming this as 1, direction of current is assumed. This is 2 and this is 3. Mesh number 1, mesh number 2 and mesh number 3. Then polarity positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. This will be positive, this will be negative. So first is apply KVL. Apply KVL to loop number or mesh number 1. When I apply KVL to mesh number 1, I get positive to negative minus 3I2, positive to negative minus 2, I2 minus I3 and plus 5 I1 minus I2 equal to 0. So minus 3I2 minus 2I2 plus 2I3, 5I1 minus 5I2 equal to 0. So 5I1 minus 10I2 plus 2I3 equal to 0. Equation number 1. Apply KVL to loop number 2 starting from this point. Positive to negative minus 4 I1, positive to negative minus 5 I1 minus I2, positive to negative minus 4 I1 minus I3 equal to 0. So minus 4 I1 minus 5 I1 plus 5 I2 minus 4i1 plus 4i3 equal to 0. So this is minus 13i1 plus 5i2 plus 4i3 equal to 0. Equation number 2. Next is apply KVL to loop number 3. When I apply KVL to loop number 3, starting from this point, negative to positive. So plus 4i1 minus i3 plus 2i2 minus i3 minus 12 minus 4i3 equal to 0. So 4i1 minus 4i3 plus 2i2 minus 2i3 minus 12 minus 4i3 equal to 0. So 4i1, then i2 is plus 2i2 minus 10 i3 equal to 12. Equation number 3. So solve the 3 equations simultaneously. When I solve the equation simultaneously, what do I get? 5i1 minus 10i2 2i3 minus 13i1 5i2 then minus 13 5 4 0 4 2 minus 10 12 so current through 12 volt is I3, which is 1.6623 ampere in the above upward direction, because the answer for I3 which we are getting is minus 1.6623 amperes. So the current should not be negative. So the answer which we write is a positive current, but the direction is the opposite direction. So I3 we have shown downward. So assumption for I3 is wrong because current we are getting negative. So we say that I3 is going in the upward direction with a current of positive 1.6623 amperes. Let's see the next question. Question number 4. Question number 4 is find the current. Find current in 2 ohm resistor. Find current in 2 ohm resistor. So this is given as 10 volt. This is 6 ohms. This is 1 ohm. This is 2 ohms. This is 3 ohms. This is 10 ohms. And this is 20 volts. So we will have done a similar sum of this type. So first we have to understand that current through 2 ohm is asked. So this is the 2 ohm resistor. First we have to assume the direction of current. So I1 flows like this, I1, I1, I2. So this will be I1 minus I2. This is I3. This will be I2 minus I3. This will be I3. This will be I3. So this will be I2 minus I3 plus I3. I3 cancel. I2. This will be I1 minus I2 plus I2. I2 cancel. So I1. Then we have to mark the polarity. This is negative. This is positive. Plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. Then we have to apply KVL. So consider this loop number 1, loop number 2, loop number 3. So first step is apply KVL to loop number 1. When I apply KVL to loop number 1, starting from this end, I say negative to positive plus 10, positive to negative minus 6, I1, positive to negative minus 1, I1 minus I2 equal to 0. So 10 minus 6 I1 minus I1 plus I2 equal to 0. So this is minus 7 I1 plus I2 plus 0 I3 equal to minus 10, equation number 1. Then I say apply KVL to loop number 3. When I apply KVL to loop number 2, starting from this point, negative to positive plus 1, I1 minus I2, I am applying in the clockwise direction. Positive to negative minus 2, I2, positive to negative minus 3, I2 minus I3 equal to 0. So 1 I1 minus I2 minus 2 I2 minus 3 I2 plus 3 I3 equal to 0. So I1 minus 6 I2 plus 3 I3 equal to 0, equation number 2. Next is apply KVL to loop number 3. When I apply KVL to loop number 3, starting from this point, negative to positive plus 3 I2 minus I3, then positive to negative minus 10 I3 minus 20 equal to 0. So 3 I2 minus 3 I3 minus 10 I3 minus 20 equal to 0. So 0 I1 plus 3 I2 minus 13 I3 equal to 20, equation number 3. 3 equations are there. We have to solve them simultaneously. So minus 7, 1, 0, minus 10. Then you have 1, minus 6, 3, 0. Then 0, 3, minus 13, 20 equal to. So I am getting as I1 is equal to 1.3404 amperes, I2 equal to minus 0.6170 amperes, and I3 equal to minus 1.6808 amperes. So current flowing through the 2 ohm resistor current flowing through 2 ohm resistor. 2 ohm resistor is I2, which is equal to 0.6170 amperes, but in the left direction, because this we got in the right direction. But current is not flowing in the right direction, current is flowing in the left direction. Answer is positive and current flows in the left direction. Answer is negative. My assumption for current is wrong. The assumption for current is wrong. So answer should be always positive.